Welcome to this scientific lecture on talent combinatorics. Today we're going to explore a fascinating phenomenon: why rare combinations of good enough skills often beat world-class performance in a single domain. Let me start by asking you a fundamental question. What gives you more competitive advantage? Being in the top 1% of one skill, or being in the top 25% of 3 different skills? The answer might surprise you. Let's explore this using probability theory and combinatorial mathematics. First, let's analyze the traditional path: becoming world-class in a single domain. To reach the top 1% in any competitive field requires approximately 10,000 hours of deliberate practice. This is the path of mastery. The probability of being in the top 1% is, by definition, 0.01 or 1%. Imagine a field with 1 million practitioners. Only 10,000 people will be in the top 1%. 1 million times 0.01 equals 10,000 people in the elite tier. The competition at this level is absolutely brutal. You're competing against people who have dedicated their entire lives to this single pursuit. Now let's explore the alternative, the talent stack. Instead of becoming world-class in one skill, you become good enough in multiple complementary skills. Being in the 75th percentile means you're better than 3 out of 4 people. This is achievable with much less time investment. So what is the mathematical advantage here? Let me show you the combinatorial probability calculation. The probability of being in the top 25% of any single skill is 0.25. Now here's where it gets interesting. If these skills are independent, the probability of having all 3 is the product. The probability of being in the top 25% of all 3 skills is 0.25 times 0.25 times 0.25. This equals 0.015625, or about 1.56%. Wait a moment. You might think, that's worse than being top 1%. But here's the critical insight we're missing. The key is that we're not just calculating rarity. We're calculating the rarity of a specific combination in a relevant market. In the actual marketplace, very few people have invested time in developing all 3 of these specific skills. The intersection is much smaller than the simple probability suggests. Let me give you a concrete example. Scott Adams, the creator of Dilbert, describes himself as not the best artist, not the best writer, and not the funniest comedian. His talent stack includes drawing skills at about the 75th percentile, writing skills at about the 75th percentile, and humor at about the 75th percentile. But the combination of these 3 skills at the 75th percentile created one of the most successful comic strips in history. This is the power of talent stacking. Now let's derive a more sophisticated model. The value of a talent stack doesn't just add linearly, it multiplies through network effects. The value V equals a constant k times the product from I equals 1 to n of S sub I to the power alpha, where S sub I represents the skill level in domain I. What does alpha represent? Alpha is the synergy coefficient. When skills are highly complementary, alpha is greater than 1. When alpha is greater than 1, we have synergy. The whole becomes greater than the sum of its parts. Let's calculate a concrete example. Suppose we have 3 skills, each at the 75th percentile, so skill level equals 0.75. The value of the stack equals k times 0.75 cubed times a synergy factor. Compare this to a single world-class skill where someone has skill level 0.99. The value of the single skill equals k times 0.99 to the first power. If the synergy factor is even just 2.5, which is quite conservative, the talent stack often produces more unique value. Now let's analyze the time investment required. This is where the mathematics becomes really compelling. To reach world-class level requires approximately 10,000 hours, but to reach the 75th percentile in a skill typically requires only 1,000 hours of focused practice. This means you need only 3,000 total hours to build a 3-skill stack. That's 70% less time investment for potentially more unique market value. Let me show you a visualization of how rarity changes with the number of skills in your stack. This graph shows rarity as a function of the number of skills. With 1 skill at 75th percentile, you're 1 in 4. With 2 skills, 1 in 16. With 3 skills, you're 1 in 64 people. Notice the exponential growth. Each additional skill at the 75th percentile makes you 4 times rarer in the combination space. Let's examine another real-world case study. Consider the field of technical writing for software documentation. A successful technical writer needs writing ability at the 75th percentile, software engineering knowledge at the 75th percentile, and visual design skills at the 75th percentile. The intersection of these 3 skills creates enormous value because very few people invest in all 3 domains. The probability of someone having all 3 at the 75th percentile is approximately 1.5%. But in the relevant job market for technical writing positions, you're even rarer because most applicants come from only 1 or 2 of these backgrounds. Here's another critical insight: selection bias in talent pools. Let me ask you a question. Why does the talent stack work so well? The answer lies in how people self-select into careers and skill development. Most people choose to specialize deeply in one domain. This creates intense competition at the top, but very few people deliberately build complementary skill stacks. Market dynamics strongly favor rare combinations. When supply is low and demand exists, your value increases dramatically. Now let's get more rigorous about quantifying synergy between skills. We can model this using an adjacency matrix. The adjacency matrix A has elements S sub ij representing the synergy coefficient between skill I and skill j. High synergy values mean the skills amplify each other. For example, programming and statistics have high synergy for data science. How do we choose which skills to stack? This is the strategic question. I propose a systematic algorithm for selecting skills to add to your stack. Step 1. Identify your strongest existing skill. This becomes your anchor. Step 2. Map out skills that have high synergy with your anchor skill. Step 3. Assess market demand for specific combinations. Look for underserved niches. Step 4. Calculate learning efficiency. Some skills have high initial returns, others require more time to reach useful competency. Start with your anchor skill and evaluate adjacent options based on synergy, market demand, and learning efficiency. One more critical concept: the diminishing returns of adding more skills to your stack. This graph shows marginal value versus number of skills. Notice that after about 3 to 5 skills, the marginal value of adding another skill decreases significantly. Why does this happen? Because maintaining competency in many skills requires ongoing practice, and cognitive load increases. Let me show you one more mathematical model that explains why stacks create exponential value. The total value equals base value times the product from I equals 1 to n of quantity 1 plus m sub I, where m sub I is the multiplier effect of skill I. Each additional skill acts as a multiplier on your base value, not just an additive contribution. This is why stacks create exponential returns. The multiplier m sub I equals skill level s sub I times complementarity coefficient c sub I. Let's work through a concrete numerical example. Suppose your base value in the market is $50,000 per year. Base value equals $50,000. You add skill A at level 0.75 with complementarity coefficient 0.3. The multiplier for skill A is 0.75 times 0.3 equals 0.225. You add skill B with similar parameters, giving another multiplier of 0.225. Your new value equals 50,000 times 1.225 times 1.225 equals $75,031. That's a 50% increase in market value from adding just 2 complementary skills at the 75th percentile. Now let's discuss what I call the invention space. This is where talent stacking creates true innovative power. When you have knowledge from 2 or more different domains, you can see connections that specialists in either domain cannot see. This intersection is the invention space. Historical analysis shows that most breakthrough innovations happen at the boundaries between established domains, not deep within a single domain. Consider Steve Jobs. His famous calligraphy class seemed irrelevant to computer science. His talent stack included basic programming knowledge, design aesthetics from calligraphy, and business acumen from running a company. The combination of technology, design, and business created products that revolutionized multiple industries. Jobs wasn't the best engineer, wasn't the best designer, and wasn't the best businessman, but the combination was unprecedented. We can model the probability of generating novel insights using combinatorial mathematics. The probability of a novel insight equals 1 minus the product from I equals 1 to n of quantity 1 minus p sub I, where p sub I is the innovation probability in domain I. The more domains you have expertise in, the more opportunities for cross-pollination of ideas. With 3 domains and 10% innovation probability in each, your overall probability of generating a novel insight is about 27%. We must also consider skill decay. Skills atrophy without practice. Skill level as a function of time equals initial skill level times e to the negative lambda t, where lambda is the decay rate. Different skills have different decay rates. Motor skills decay slower than factual knowledge. This graph shows skill retention over time. The green curve shows decay with minimal maintenance practice. The red curve shows rapid decay without any practice. A good maintenance strategy is to rotate your focus among your skill stack every 6 to 12 months, spending time refreshing each skill. Let me introduce the portfolio theory of skills, borrowed from financial mathematics. Portfolio return R sub p equals the sum from I equals 1 to n of W sub I times R sub I, where W sub I is the weight of skill I. Just like financial portfolios, diversifying your skill set reduces career risk. If one industry declines, you have other options. Portfolio variance equals the double sum of W sub I W sub j sigma sub ij, representing the covariance between skills. Skills that are negatively correlated in terms of market demand provide the best risk protection. For example, automation-resistant creative skills paired with technical skills. How do you measure return on investment for your talent stack? Here's a framework. Return on investment equals value after minus value before minus cost, all divided by cost. Cost C includes time invested, money spent on learning resources, and opportunity cost of what else you could have done. Track and measure your progress quantitatively using the metrics we've outlined. Let me give you a decision matrix for selecting which skill to add next to your stack. Create a matrix with criteria in rows and candidate skills in columns. Weight each criterion by importance, score each skill, and calculate weighted totals. This quantitative approach removes emotional bias from your skill development decisions. The Pareto principle applies powerfully to skill development. 80% of useful competency comes from 20% of possible knowledge. Focus on the 20% of each skill that provides 80% of the practical value. This is the core competency zone for talent stacking. You don't need to know everything in each domain. Focus on the high-value fundamentals and the specific areas with cross-domain synergy. Here's a fascinating property. Talent stacks exhibit network effects similar to social networks. Value is proportional to n times n minus 1, where n is the number of skills. Why does this relationship hold? Because the connections between skills create value, and the number of possible connections grows quadratically. With 3 skills, you have 6 possible pairwise connections. With 5 skills, you have 20 possible connections. Each connection between skills is a potential source of innovation and unique value creation. Let me outline the most common mistakes people make when building talent stacks. Mistake 1. Choosing skills with low synergy. Random skill collection doesn't create value. Mistake 2. Going too deep in one skill before establishing breadth. Get to 75th percentile in multiple skills before pursuing mastery. Mistake 3. Ignoring market demand. Your stack must solve problems people will pay for. Mistake 4. Adding too many skills. Beyond 5 or 6, maintenance becomes difficult and synergy decreases. Different skills have different learning curves. Understanding this helps optimize your development path. The green curve shows a skill with rapid initial progress. The red curve shows a skill requiring more foundational work. Choose fast learning skills for your stack when starting out. Prioritize skills with steep early learning curves. These give you the fastest return on time investment. Let me give you a concrete implementation strategy you can use starting today. Months 1 through 3. Audit your current skills. Identify your anchor skill and assess where you stand. Months 4 through 6. Research complementary skills in adjacent domains. Look for high synergy opportunities. Months 7 through 12. Begin deliberate practice in your second skill. Aim for 75th percentile. Year 2. Add your third skill while maintaining skills 1 and 2 with periodic practice. Year 3. Optimize your stack based on market feedback. Test your unique value proposition. Here's the most powerful insight. Talent stacks compound over time. Value as a function of time equals initial value times quantity 1 plus growth rate to the power t. Your growth rate R increases as your talent stack becomes more complete and rare. The blue line shows value growth for a single skill specialist at 20% per year. The green line shows a talent stack builder at 50% per year. The gap widens exponentially. Over a 10-year period, the difference in career trajectory is enormous due to compounding effects. Let me summarize the key mathematical principles we've covered. Principle 1. Rarity compounds multiplicatively. Each skill at 75th percentile makes you 4 times rarer. Principle 2. Value exhibits network effects proportional to n squared due to skill connections. Principle 3. Time investment is about 70% less than achieving world-class status in a single skill. Principle 4. Synergy multiplies value when skills are complementary rather than redundant. Principle 5. The optimal stack size is 3 to 5 complementary skills for most applications. Principle 6. Innovation and unique insights emerge at the boundaries between domains. Here are your concrete action steps based on this lecture. Step 1. Calculate your current market rarity using the multiplicative probability model we discussed. Step 2. Identify 2 to 3 high synergy adjacent skills to your current expertise. Step 3. Develop a 12-month learning plan to reach 75th percentile in your next skill. Step 4. Track and measure your progress quantitatively using the metrics we've outlined. Step 5. Test your unique value proposition in the market through projects or consulting. In conclusion, the mathematics of talent stacking reveals a profound truth about modern career development. We've moved from a depth-only model where mastery was the only path to a strategic breadth model where rare combinations create unprecedented value. The old model was linear and competitive. The new model is exponential and strategic. Your unique combination of skills becomes your competitive moat. It's difficult for others to replicate because it reflects your specific journey and choices. The future belongs to creative combiners who can synthesize insights across domains, not just to deep specialists in narrow fields. Thank you for your attention. The mathematics clearly shows that strategic skill combination offers remarkable advantages in the modern economy.